Exercise 5.2, just a few homework questions. To solve this equation from 0 to 2 pi, was it? Yes? So solve for x from 0, x lies between 0 and 2 pi. So ladies, for a start, you need to, there often will be a hint for this sort of question to show that sine 3x equals some other expression. If you look at this, we can't solve this while we've got a triple angle and a single angle in the same question. Sine of 2x, come on, expand it please, sums and differences of angles. Cos x plus cos of 2x sine x. Now when you do the sine 3x expansion, we like to get everything, when we finish it, in terms of sine x. So remember, we've got three options for what we're going to change cos 2x into. Now what's sine 2x? There's only one expansion for sine 2x. It's 2 sine x cos x, but then you're timesing by another cos x. So can I just write cos squared x now? Oh, I'll just write cos x. Plus, which result for cos of 2x should you use? There's three to choose from. I would definitely use 1 minus 2 sine squared x. And then we're timesing that again by sine x. So now I've got 2 sine x times cos x is cos squared x. How can you write that in terms of sine squared x? Isn't that? What's cos squared x? 1 minus sine squared x, not 2 sine squared x. That is cos squared x. That's the 2-unit result. So what I've just done there is cos squared x, remember, plus sine squared x equals 1. So this cos squared x here, cos x times cos x is cos squared x. This is the 2-unit result that cos squared x plus sine squared x is 1. So cos squared x is 1 minus 2 sine squared x. Please don't get it mixed up with cos of 2x, which is 1 minus 2 sine squared x. Now I'm going to expand this bracket and I get plus sine x. Then I've got minus 2 sine cubed x. Now expanding this bracket again, you've got 2 sine x. Keep going. What else have we got? Minus 2 sine cubed x plus sine x minus 2 sine cubed x. So, collecting like terms, what have we got? 3 sine x minus 4 sine cubed x. Now, girls, you can be asked, often if they want you to solve that equation, they'll give you a hint. They'll say, show that sine 3x equals this, hence solve. So now that we want to solve that equation, sine of 3x plus sine of x is 0. We're just going to replace the sine of 3x with 3 sine x minus 4 sine cubed x plus sine x is 0. So I'm just replacing the sine 3x with what we've just done in part A of the question. Now what do I do? Come on. Have I got like terms? So I've just replaced the sine 3x with 3 sine x minus 4 sine cubed x. Now they're all single angles, but do I have like terms there? Do we get that? Guys, sine 3x is 3 sine x minus 4 sine cubed x from the part above. So now I've got 4 sine x minus 4 sine cubed x equals 0. How do I solve this? Factorize, not divide through by sine x, otherwise you'll lose a solution. I factorize, and I'm going to take out 4 sine x as a common factor, and what have I got? 1 minus sine squared x, which is cos squared x, that's right, it is. You could, or we can just do it as, so 4 sine x equals 0, or 1 minus sine squared x is 0, and now we can write that as cos squared x is 0. Now, was this a general solution question or was it just solve? Solve. Okay. So if 4 sine x is 0, that means that sine x is 0. So you can just draw your little sine curve. and cos squared x is 0. It's just like solving cos x is 0. So what are our solutions going to be? So we've got, well, be careful with the first one because you've got more than, what are your solutions? 0, pi, 2 pi. What about the other one? Pi on 2 and 3 pi on 2. Is to solve this giving general solution, all right, for x. When you see sine x plus cos x is a constant as opposed to 0, you have to use either the t method, t formula, or the auxiliary angle method. So what do you want to try? However, with auxiliary angle method, you have to write sine x plus cos x in terms of sine x plus alpha. Put it in that form first, with an r in front. So first you have to write sine x plus cos x in that form first. R sine x plus alpha. So how do we do that? R, expand, sine x cos alpha plus, I'm going to write the r in front as well instead of going r bracket, cos x sine alpha. Remember we swapped them around? So r cos alpha sine x plus r sine alpha cos x. And then as you equate your terms on the left-hand side and the right-hand side, you can see the sine x's there are the same and the cos x's are there. So now what we say that r cos alpha is, anyone? And r sine alpha is also 1. So sine alpha and cos alpha are both 1 on r. You keep going. We use our right angle triangle and r will be the square root of 1 squared plus 1 squared, it's the square root of 2. And the tan of alpha is opposite over adjacent, which is 1. So alpha is 45 degrees or pi on 4. And so you get that. Therefore, we can say that sine x plus cos x really can be written as root 2 sine x plus pi on 4. Now we have to rewrite the question and the solution. So hence, to try and solve sine x plus cos x is 1, you rewrite the question as root 2 sine x plus alpha pi on 4, equals 1. So now this becomes like what we were doing last lesson. Solve that. So now, what am I going to do with this to solve it? What should I do with the root 2? Yeah, make it sine of x plus pi on 4 is 1 on root 2. Now we'll use our general solution method. Sine of what is 1 on root 2? Sine of 45, isn't it? So we can say that the acute angle pi on 4, acute angle x plus pi on 4 is pi on 4. I know that's a bit weird. The sine of pi on 4 is that. But how do we write the general solution? So the general solution, isn't it that x plus pi on 4 is, what's the formula given to you for general solution? So we know that sine of 45 is 1 on root 2, or sine of pi on 4 is 1 on root 2. The general solution is that thing is, isn't it pi n plus negative 1 to the power of n times the acute angle, which is pi on 4. So now take the pi on 4 over. We get x is pi n minus negative 1 to the power of n, pi on 4, minus pi on 4. Wait. Still plus. Now we've got, this is looks like a bit of a complicated solution. See, n is any integer, okay? So we've got two scenarios here. We're just going to investigate them if n is even or if n is odd. We're just going to have a look at that, okay? Just want to investigate this. So if n is even, my first solution would be pi n plus, now girls, what's negative 1 to the power of n? If n is even, that's negative 1 squared, negative 1 to the power of 4. Doesn't it just become 1? So it'll become plus, and it doesn't matter how big it gets. You'll just get a normal 1. Do you get it? You get 1 times pi on 4 minus pi on 4, pi n. And if n is odd, we get x is pi n. Now, if n is odd, this negative 1 to the power of n would just be negative 1. If you've got n is 1, n is 3, n is 5, you would have plus negative 1 times pi on 4 minus pi on 4 would still be there. So you'd have pi on 4, what? Minus pi on 4 minus pi on 4, minus a quarter is minus a half. So it's minus pi on 2. Solutions, let's see if it works. So my formula, or the question was solve sine of x plus cos of x is 1. That was the question. Okay, so when n is even, for example, if n is 2, what's sine of 2 pi? 0. What's cos of 2 pi? 1. That works. Look, there's the sine curve, there's the cos curve. When n is 0, for example, looking like even, you get sine of 0, which is 0, that's the sine curve, plus cos of 0 is 1, that gives you 1. When n is 2, watching, sine of 2 pi from here is 0, sine of 2 pi here is 1. 0 plus 1 is 1. It works. Okay? Let's look at this one. If n is odd. So these are my solutions. When you've got a sine one and you've got 3 components to it, you can often be asked to give the solution if n is even and if n is odd. That is the solution there, but you can simplify it into if n is even or n is odd. Let's look at this one if n is odd. For example, if n is 1, what would you get here? Pi minus pi on 2, that's pi on 2, isn't it? So I'm looking at sine of 90, or sine of pi on 2. Sine of pi on 2 is 1. Here, sine of pi on 2 is 0. 1 plus 0 is 1. That works. Let's do if n is 3. What's 3 pi minus half pi? Is 2.5 pi. So I could continue it along. I'd have to continue my graph, because that only goes up to 2 pi. 2.5 pi is up here and down there. And one of them will be 1 and one of them will be 0. And that works as well. Okay? So these are the solutions. It's got the cos sine. So that one's got to be written as a cos, and when it starts with cos, the sign here is different. The reason the sign's different is that when you do the expansion, it's cos minus sine sine. See, the reason you write it as plus is that when you do the expansion, it becomes minus and then it matches up. So what's what? There's your cos x, and there's your cos x, and there's your sine x, and there's your sine x. Oh, okay. So you can equate your terms, and you've got that r cos alpha is root 3, and this other one, r sine alpha is 1. Not negative 1, it's 1, because there are 2 minus signs there, and they're the same. So r sine alpha is just 1. So you can do up your right angle triangle, use your auxiliary angle method, and work out that the r and your angle. Okay? Cos is adjacent and sine is opposite. Off you go. G, again, recognizing it as an auxiliary angle method, and that it would be r cos x plus alpha, expanding that, equating the parts. You'll end up with r is 2 and alpha is pi on 6. So then we're just going to rewrite root 3 cos x minus sine x to be 2 cos x plus pi on 6. You replace this left-hand side of the equation with that and solve. And so the question now becomes 2 cos x plus pi on 6 is 1. So you're solving or finding the general solution to cos of x plus pi on 6 is a half. What's your acute angle? Acute angle x plus pi on 6. Cos of what is a half? Cos of 60, which is pi on 3. Then your general solution, sine of 30 is the same as cos 60. Quadrant 1 or 4 is where cos is positive. You take the smaller one. So x plus pi on 6, remember it's 2 pi n plus or minus pi on 3. Okay? Now, actually, I would like to write this as 2 solutions instead of 1. All right? They should have actually written as 2 solutions. So what do we do now? X is 2 pi n plus or minus pi on 3. What do I write next? Minus pi on 6. You should be writing 2 solutions. I wouldn't write it like that. So it's 2 pi n plus pi on 3 minus pi on 6. What's the other solution? 2 pi n. What's the other solution? Minus pi on 3 minus pi on 6. So this should be written with 2 solutions. Remember, pi on 3 is 2 pi on 6. What do you get? A third minus a sixth is a sixth. What do you get for the other one? Well, that's 2 pi on 6. Well, you got 2 pi on 6 minus 2 pi on 6 minus, well, it's minus a half. Minus pi on 2. You subtract pi on 6, but you've got to do, you know how one of the solutions is 2 pi on n plus pi on 3, then you subtract the pi on 6. The other solution is 2 pi n minus pi on 3 minus pi on 6. It is not what, I think there's an error in the book.